Alright, so we're going to discuss how to do derivations using the basic derivation system for predicate logic, which is called PDE, or predicate derivation system. And we're going to start by checking the validity of a pretty simple argument here, which kind of follows a pattern that you guys should recognize from Sentinel logic. Yeah, and even though predicate logic has a more complex syntax than Sentinel logic, I think you'll find that its derivation system is easier to pick up because it's pretty much the one that you know from before, just with a few rules for quantifiers thrown in. Alright, so what does this argument say? It says for everything in the universe of discourse, if it's F, then it's G. If it's G, then it's H. Therefore, if it's F, then it's H. And a little more logic-y way of saying that is for all x, if x is F, then x is G. For all x, if x is G, then x is H. And for all x, if x is F, then x is H. And that should definitely seem right. That should sound valid. So let's go ahead and take a look at how to prove this. So anytime we're trying to prove a conclusion that's universally quantified, probably we're going to use universal introduction to get this, right? Unless there's a way we could do it with like negation elimination or something. But what we're going to do is get this, we're going to get the same formula using some constant and then use universal introduction on it, right? And there's a couple of restrictions to doing that. We'll discuss them later, but you have to be a little bit careful doing it. But let's start working from the top down now. So what we want to do, this is what we want to get. So we have to take these quantifiers off. And fortunately, universal elimination is a really easy rule to use. We just take the quantifier off and rewrite the formula, replacing the variable with a constant. And remember, constants are the letters from the start of the alphabet. They're like A, B, C, lowercase letters. And, like X, Y, Z, W, those are variables. And those play very different roles in this kind of logic. Constants are picking out objects in the domain. They're names that we're using to reason about things in our domain, or our universe of discourse, whereas variables are being used just to indicate binding with quantifiers. Okay, so they're very different things. So anyway, now we're ready to do this one. So notice I could have used any letter, any constant I wanted here again. But obviously, I want to use this same one so I can reason about these to use these together. And now, at least this part of the proof, this is pretty much going to run just like this is just like a proof of Sentinel logic, because these are just like as far as the derivations are concerned, we can handle these just like a P or a Q or something of Sentinel logic. So getting this is just a straightforward case of using conditional introduction now. So again, we're trying to prove a conditional. We assume the antecedent. We want to show that the consequence follows. Okay. So from FA, the assumption of FA, we get GA by conditional elimination, lines 3 and 5. Okay, now we have HA already by lines 4 and 6, conditional elimination. Okay, so we can use, we've shown on the assumption of FA that HA follows. So we can use conditional introduction now, lines 5 through 7. And now we can go ahead and use universal introduction on this line. Now, as I said, you have to be a little bit careful using this rule. There's a couple of restrictions on it. One of them is this constant. So the restrictions are all on the constant that you're quantifying over, right? The constant that you're going to replace with a variable. And the first one is it can't be in any open assumptions, right? And it isn't an assumption here. But notice it's closed. That's closed. We're out of this subderivation. The only open assumptions we have are here, and we don't have this constant in either one of those. And that rule, it kind of reflects the fact that you can't just assume something and then say it applies to everything, right? And also, the constant that you're quantifying over, it can't be in it can't be anywhere in the sentence that you're getting, right? So like that wouldn't be okay, right? If this A was somewhere in this sentence, that's not all right. Okay, so now we're going to go ahead and we're going to put the quantifier on. So we get our conclusion by universal introduction on line 8. And we're done.